So the project I chose to do is distribution, and it's crucial in engineering because it determines how the internal forces spread throughout the material, and it tells if the material is going to break or not, so if it's good for design. It highlights the structural safety, failure, and also material selection. It also can highlight critical points, which will appear when it crosses zero, and that deals with you can go into shear force diagrams as well, but that's very important because it will depend if your material will break or if you have the correct material chosen. But this is a stress distribution, and over here I made functions of labels of length, the load, position, load type drop, and also max stress. So basically all you do is put in your values here and hit calculate, and then it will give you a distribution. So I chose to do a length of 100, load of 50, position of 10, and then we're going to run it. And then hit calculate. And this is the point for it. Also, if you hit distributed, the curve changes. The units are in pascals. Well, I guess technically 10 to the 6, so that's megapascals. And the X is the beam length. Over here, we have code view. And this was built into MATLAB for the app design. And the inputs I made were the L is the beam length, P is the load magnitude, A is the load position, and then the load type, it interchanges between point and distributed. And then you can hit that with the drop down right here. Along with the code view after that, I had to do the beam cross section, and all of this is in meters. So you have the width, which is B, height, which is H, and then moment of inertia, which is base height cubed over 12. And then when you find C, that's distance from the neutral axis, and C is half of the height. And this is all important because this helps get your graph correct. So after that, I defined the position along the beam, and then I made the moment array here. After that, I did the creating the if or if else loop for the moment calculations, which is based on the load type. And the load type is also interchangeable. So you can change it to, I don't know, like 1,000 or like 1,000,000 or whatever you want to do. And then the graph will correlate with that. And then calculating the max bending stress, it's sigma m times c over I, which we defined earlier up here. And then this, going into that, it plots the stress distribution, and then it also displays the max stress in pascals, or 10 to the 6, which is megapascals. And then we can run it again, and I can change the values for it. So we can do length of 150. Load, we can do 100. Position, I don't know, let's do 50. And then max stress, let's change it to 2,000. Hit calculate, and there it is, the stress distribution. And I'm gonna hit the load type drop down and hit calculate again, and then you get a different curve. So this was my project. Along with the code view, I'll show that again. This was the built-in. And then this is what I wrote for everything. The hardest part was figuring out the buttons and trying to get that into it and just compiling everything, but everything went pretty well. I would just say figuring out the buttons and functions was pretty good once I learned how to do it. All right, thank you.